Hi everybody. So in this video, we're going to look at mutually exclusive events. We'll work through these examples and then we'll try some exam style questions. And if you want to work along with me, you can download a copy of this PDF from my website. I'll leave a link below. So mutually exclusive events are events that cannot happen at the same time. If one event occurs, the other cannot. So if we take the example of rolling a dice, we can have event A, which is rolling an even number. So the numbers 2, 4, or 6 on a six-sided dice, or event B, rolling an odd number. So the numbers 1, 3, and 5. Since a number cannot be both even and odd at the same time, these two events are mutually exclusive. In simple terms, if one event happens, then the other event is impossible. So as we progress through this video, we're going to be using this idea. So if we look at example 1, we're told that Taylor rolls a biased dice once, and the probability that he gets the number 5 is 0.4. Work out the probability that Taylor does not get the number 5. So these are mutually exclusive. You can either get a 5, or you can get a not 5, which is 5 dash. This dash means not 5. And because one of these two things must happen, they add together to make 1, and this 1 means certain. So we're told that the probability of getting the 5 is 0.4, so plus the probability of not 5 must make 1. So a probability of not getting the 5 would be 1 take away the 0.4. So this will be 0.6. Okay? For example 2, Emma spins a bias spinner once. The probability that it lands on a red is 0.35. Work out the probability that Emma does not get a red. So do you want to try this question yourself? So the probability of a red or a not red are mutually exclusive. They can't both happen. So they must add together to make 1. One of these will happen, but they can't both happen at the same time. And we're told that the probability of a red is 0.35. So we're looking at the probability of a not red. And they will add together to make 1. So a probability of a not red will be 1 minus the 0.35, which is 0.65. Okay? Let's try some more questions. So in example 3, we're given the four-sided spinner and we're told that it's biased. The table shows the probabilities for red, orange, and green. We've been asked to work out the probability that the spinner will land on blue. So if we use the idea of mutual exclusivity, we either get the probability of blue or not blue. And together, they add to make 1. So these are our mutually exclusive events. So we need to work out the probability of it not being blue, which means it would be any of the other colours. So this would be the probability of it being red, or the probability of it being green, or the probability of it being orange. So we can add these together. We get the 0.2 plus the 0.3 plus the 0.1. So they add to make 0.6. So then the probability of being blue will be the 1 minus the 0.6. So this will be 0.4. Okay? Let's try example 4. So in example 4, we're told that a vending machine contains a variety of soft drinks. A person selects a drink at random from a machine. Some of the probabilities of selecting each drink are shown in the table below. Calculate the probability that the chosen drink is iced tea. So do you want to try this question yourself? You can pause the video and come back when you're ready. So our events are either it is iced tea or it isn't, which is the complement of that IT. Together they make 1. And if it's not iced tea, then it must be cola or lemonade or orange juice or apple juice. So we can work these out. We've got 0.3 plus the 0.12, 0.25, and the 0.28. And when we add these together, we get 0.95. So the probability of it being iced tea will be equal to 1 minus the 0.95, which is 0.05. Okay, let's try one final question. So in example 5, we're told that a box contains only pencils, pens, and erasers, and the number of pencils in a box is the same as the number of pens. Sophia picks an item at random from a box, and the probability that she picks an eraser is 0.3. Work out the probability that the item Sophia picks is a pencil. So do you want to try this question yourself? You can pause the video and come back when you're ready. Okay, so how did you get on? We know we've got a pencil, pen, and an eraser. And we're told that the probability of getting an eraser is 0.3. We're also told that the number of pencils is the same as the number of pens. So the probability of a pencil and a pen will be equal. So either we're getting an eraser or it's not an eraser. And together, they'll add to make 1. So the probability of not getting an eraser will be 1 minus the 0.3, which is 0.7. And because the two probabilities are equal, the probability of getting a pencil will be half of that, 0.35. The same for a pen. So the probability of getting a pencil will be 0.35. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the full lesson and the PDF that accompanies this video from my website, mrmathematics.com.